Why is space black? If space is filled with stars that emit light, shouldn't space be bright and colorful? Why is there light on Earth but not in space? The vast expanse of outer space has always been a source of wonder and curiosity for humans. As we gaze at the night sky, we are mesmerized by the beauty of the stars, galaxies, and nebulae. Let's explore the reasons behind the darkness of space and delve into the fascinating science behind this phenomenon. The nature of light. To understand why space appears black, we must first understand the nature of light. Light is a form of electromagnetic radiation that travels in waves. These waves have different wavelengths, and the range of wavelengths that our eyes can perceive is known as the visible spectrum. The visible spectrum includes all the colors we see in a rainbow, from red to violet. When light encounters an object, it can either be absorbed, reflected, or transmitted. If an object absorbs all the light that falls on it, it appears black, as no light is reflected back to our eyes. On the other hand, if an object reflects all the light that falls on it, it appears white, as all the colors of the visible spectrum are reflected back to our eyes. Objects that reflect only certain wavelengths of light appear colored, as they absorb some wavelengths and reflect others. The absence of light. Now, let's consider the vastness of space. Space is unimaginably vast, with billions of stars, galaxies, and other celestial objects scattered across incomprehensible distances. These objects emit light in the form of electromagnetic radiation, including visible light. So, if space is filled with light-emitting objects, why does it appear dark? The answer lies in the vastness of space itself. Space is mostly empty, with a very low density of matter. This means that there are few particles, such as atoms and molecules, present in space to interact with light. Without particles to scatter or absorb light, it simply travels through space undisturbed, continuing on its path until it encounters an object. When light from a distant star or galaxy travels through space towards us, it encounters very little matter along the way. Most of the light passes through the vast emptiness of space without being absorbed, reflected, or scattered. As a result, by the time it reaches our eyes or telescopes, it appears to be coming from a black background, as there are no objects to reflect or scatter the light towards us. This phenomenon is similar to looking at a clear night sky away from city lights. On a moonless night, when there are no clouds or other objects to scatter light, the sky appears dark, and we see countless stars shining against a black background. Similarly, in space, the absence of matter to scatter or absorb light makes it appear black to our eyes. Cosmic background radiation. While space appears black to our eyes, it is not completely devoid of all forms of radiation. In fact, there is a form of radiation called cosmic background radiation that spreads throughout the universe and fills space with a very low level of energy. Cosmic background radiation is a type of electromagnetic radiation that was first discovered in 1965 by physicists Arno Penzias and Robert Wilson. It is a faint glow of microwave radiation that is uniformly spread across the entire universe. This radiation is believed to be a remnant of the Big Bang, the event that is thought to have marked the beginning of the universe. During the Big Bang, the universe was formed in a hot and dense state, and it has been expanding and cooling ever since. As the universe expanded, it also cooled down, and the energy that was released during this process is believed to be the cosmic background radiation that we detect today. This cosmic background radiation is spread uniformly in all directions, and it has a temperature of about 2.7 Kelvin, making it one of the coldest known regions in the universe. Despite its low temperature, the cosmic background radiation is not visible to the naked eye, as it is in the form of microwaves, which are a type of electromagnetic radiation with much longer wavelengths than visible light. However, it can be detected and measured using specialized instruments, such as microwave telescopes. The cosmic background radiation is an important piece of evidence supporting the Big Bang theory, which is the prevailing scientific explanation for the origin and evolution of the universe. The fact that the universe is filled with this faint glow of microwave radiation, evenly spread across all directions, is consistent with the idea that the universe started from a hot, dense state and has been expanding and cooling over billions of years. The role of dust and gas. While space is mostly empty, there are regions in space that contain dust and gas. These regions, known as interstellar medium, are composed of tiny particles such as dust grains and gas molecules that are spread out across vast distances. These particles can play a role in the appearance of space and contribute to its darkness. When light from a star or other light-emitting object travels through space and encounters dust and gas, it can interact with these particles. Dust grains, for example, can absorb and scatter light, causing it to deviate from its original path. This scattering can scatter light in all directions, including back towards us, which can contribute to the darkness of space. Moreover, the interstellar medium can also absorb certain wavelengths of light, particularly shorter wavelengths such as ultraviolet and blue light, which are more energetic. This absorption can cause the light to be absorbed by the gas or dust particles, converting its energy into heat and preventing it from reaching our eyes or telescopes. This absorption can also contribute to the overall darkness of space. However, it's important to note that the amount of dust and gas in space is extremely low, and they are mostly concentrated in specific regions such as nebulae, where stars are forming. In most parts of space, the density of dust and gas is so low that their contribution to the darkness of space is negligible. Therefore, while dust and gas can play a role in the appearance of space, they are not the main reason why space appears black. The absence of atmosphere. Another crucial factor contributing to the darkness of space is the absence of atmosphere. Atmosphere on Earth comprises of dust, dirt, gases, and water droplets. On Earth, our atmosphere plays a significant role in scattering and reflecting sunlight, which is why we have a blue sky during the day. The atmosphere scatters shorter wavelengths of light, such as blue and violet, more than longer wavelengths, such as red, resulting in a blue coloration of the sky. However, in space, there is no atmosphere to scatter or reflect light. As a result, light from distant stars or other objects travels through space unhindered, without being scattered or reflected towards our eyes. This lack of scattering or reflecting of light is one of the reasons why space appears black to our eyes. It's worth noting that while space appears black to our eyes, it is not actually completely dark. As mentioned earlier, there is cosmic background radiation, which is a faint glow of microwave radiation left over from the Big Bang. However, this radiation is not visible to the naked eye, and it is not enough to make space appear brightly lit. Human perception of color. Another factor to consider when discussing why space appears black is human perception of color. Our eyes are adapted to perceive colors in the visible spectrum, which is the range of wavelengths of light that we can see. This visible spectrum ranges from violet, which has the shortest wavelength, to red, which has the longest wavelength. Beyond the visible spectrum, there are other wavelengths of electromagnetic radiation, such as ultraviolet and infrared, which are not visible to our eyes. Ultraviolet has shorter wavelengths than violet, while infrared has longer wavelengths than red. These wavelengths of light do exist in space, but they are not visible to our eyes, and therefore we do not perceive them as colors. Since the majority of light in space falls outside the visible spectrum, we perceive space as black. Our eyes are not sensitive to the longer wavelengths of infrared or the shorter wavelengths of ultraviolet, and as a result, we do not perceive them as colors or as light. This limitation in human perception also contributes to the darkness of space as we perceive it. Redshift and expansion of the universe. Another factor that contributes to the darkness of space is the phenomenon of redshift, which is a result of the expansion of the universe. Redshift occurs when light from distant objects, such as stars or galaxies, is stretched as the universe expands, causing its wavelength to increase and shift towards the red end of the spectrum. As the universe expands, the space between objects also expands, causing objects to move away from each other. This means that light from distant objects has to travel through expanding space to reach us, and as it does so, it gets stretched out, resulting in a shift towards longer wavelengths. The redshift phenomenon has important implications for the appearance of space. When light from a distant object, such as a galaxy, is redshifted, it means that the light has been stretched out and shifted towards longer wavelengths, including wavelengths that are outside the visible spectrum. As a result, the light may no longer fall within the visible spectrum by the time it reaches us, making the object appear dark or even invisible to our eyes. This phenomenon is similar to the Doppler effect, which is the apparent change in the frequency or wavelength of a wave as the source of the wave moves relative to the observer. When an object emitting light moves away from us, its light waves get stretched out, resulting in a redshift. This is the same principle that causes the sound of a siren on a moving vehicle to change pitch as it passes by. In the case of the universe, as it expands, objects are moving away from each other, causing light from distant objects to be redshifted and making them appear darker or even invisible to our eyes. The phenomenon of redshift and the expansion of the universe has been extensively studied and measured by astronomers. It has led to important discoveries about the age, size, and composition of the universe and has provided evidence for the Big Bang theory. The fact that distant objects in space appear redshifted, indicating that they are moving away from us and that the universe is expanding, is one of the reasons why space appears black to our eyes. It's important to note that our understanding of the darkness of space is based on our current scientific knowledge and observations. As technology advances and our understanding of the universe deepens, our understanding of the darkness of space may evolve. For example, newer telescopes and instruments may provide more insights into the interstellar medium and its role in the darkness of space, or advancements in our understanding of human perception may shed more light on how we perceive space. Space appears black due to a combination of factors, including the cosmic background radiation, the interstellar medium, the redshift and expansion of the universe, the absence of atmosphere, and human perception of color. These factors collectively contribute to the darkness of space as we perceive it with our naked eyes. Our current understanding of space and its darkness is based on our scientific knowledge and observations, and as our understanding of the universe progresses, we may uncover more insights into this intriguing phenomena. I hope you now know why is space black. If you liked the video, please consider subscribing to my channel. This will help me a lot. I'll be posting more amazing stuff on my channel. See you soon.